Hi, good morning. Today we're going to talk about part 2 of section 5.1. Recall section 5.1 is exponents. In part 1 we talked about the basic rules for exponents, and in part 2 we're going to talk about negative exponents and how to embrace techniques with dealing with negative exponents. Alright, negative exponents. First thing we have to do is define what a negative exponent is. Let's say I've got a suitable base raised to some negative exponent. Let's pretend we don't know what this is or what it's defined as. Let me do a little bit of a proof here. Suppose I take x to the minus nth power and I multiply it by an expression to a positive exponent, namely x to the minus nth power. We know from part 1 that when you multiply the same bases, you keep that same base and add the exponents. And if I add minus n to positive n, of course I get a 0 exponent. And I know from last lecture that x to the 0 power is equivalent to 1. So what I'm really saying here is x to the minus nth power times x to the nth power equals 1. And of course, if I divide both sides by x to the nth power, they'll cancel out on the left-hand side, and I get this equivalent expression, x to the minus nth power is equivalent to 1 over x to the nth power. So this is what I call my first rule for negative exponents. Let me write that down. First rule for negative exponents. We're going to have 2 rules before the day is done. Okay? Alright, so remember that. Let's do some examples using this rule. Let's say, well, I'm going to be using this acronym. Let me digress for a moment here. Simplify and express with positive exponents only. Alright, we're going to be using this instruction very many times today, so I'm going to make it a little acronym out of it using the first letters, so I don't have to keep writing this over and over again. Alright, so this instruction, simplify and express with positive exponents only, I'm going to abbreviate with this acronym, SAWPEO, S-A-E-W-P-E-O. Simplify and express with positive exponents only. Key phrase here is positive exponents only. All your answers should contain positive exponents only in their final return. Alright, so here's our first example. What's 3 to the minus 2 power? Well, remember the rule. Let me write it over again here. X to the minus nth is 1 over x to the nth. So 3 to the minus 2, by definition, is 1 over 3 squared, which is 1/9. Alright, so it's not negative 6, it's not 1 over negative 6, nothing like that. You simply take your expression, move it downstairs to the denominator level, and change the exponent from negative to positive. Right. Again, 4 to the minus 3 power, simplify and express with positive exponents only. That's equivalent to 1 over 4 cubed, and 4 cubed is 64. So final return there is 1 over 64. Let's talk about a negative exponent expression using a variable, 7 times m to the minus 8th power. How would I get a positive exponent expression only out of that? Well, notice this minus 8 exponent is working on the m base and really not affecting the 7. So this is equivalent to 7 times m to the minus 8th. Right? So m to the minus 8th is 1 over m to the 8th power. And if I multiply these expressions, 7 times 1 at the numerator level is 7. So I end up with 7 over m to the 8th power. So after a while, we can do this without the intermediate steps. Move that m to the minus 8th downstairs, changing the exponent sign, 7 over m to the 8th. Right? Simplify and express with positive exponents only. How about minus 3 raised to the minus 3 power? Alright, on test day we get all kinds of screwy answers for something like this, but just take a moment to apply the rule that we've learned. Something to the minus nth power is something, or I'm sorry, 1 over something to the nth power. So minus 3 to the minus 3 power, according to the rule, is 1 over minus 3 to the positive 3 power. Okay? And I can simplify this further. 1 over minus 3 cubed in the denominator, well, negative 3 times negative 3 times negative 3 is negative 27. And of course I can absorb this negative sign in one of 3 ways. I can absorb it either in numerator or denominator, or equivalently move it outside the quotient process and call this negative 1/27. Let's try some more variable expressions. Simplify and express with positive exponents only. X to the minus 5th power times x cubed. Alright, well, as we know from part 1, when we multiply the same bases, we keep that same base and add the exponents. Okay? And these same rules hold for negative exponents just like they do for positive exponents. Well, adding those exponents, I get a x to the minus 2, and as a new exponent, and x to the minus 2 power, of course, is equivalent to 1 over x squared. So simplify and express with positive exponents only. This should be my final return. Try another one. How about a power of a power? Alright, as we know from part 1, when you take a power of a power, we multiply the exponents. Well, if I multiply these exponents, well, that's nice. They're both negative, and I know that negative times negative is positive. So this one's a one-stepper. X to the minus 3 power raised to the minus 2 power reduces to x to the 6th power. Right? Power of a power, multiply the exponents. Alright, what about when negative exponents are in the denominators of expressions? How do we do that? Let me write that down. What about negative exponents in denominator? I'm going to deal with those, try to express those equivalently with positive exponents. Let me write a simple example here. Oops. Hang on a minute. Alright, let's, what about negative exponents in denominator? Let's say we've got something that looks like this. 1 over x to the minus n power. How are we going to simplify this? Well, take a look at this denominator. Well, we know what that denominator is. X to the minus n power is 1 over x to the nth, is it not? Alright, so I've got a number in the numerator divided by a fraction, and we know that when we divide by fractions, we equivalently invert and multiply, right? Invert that denominator expression and multiply by the numerator. Of course, factors of 1 and divisors of 1 cancel each other out, and I end up with x to the nth power. So this is my second rule for negative exponents. Now it states 1 over x to the minus n is equivalent to x to the nth power. Alright, so let's contrast that to the first rule. If I've got x to the minus n, that's 1 over x to the nth power. And my second rule says 1 over x to the minus nth is equivalent to x to the nth power. Alright, so if I've got a negative exponent at my numerator level, I move it down to denominator and change the exponent sign. And if I've got a negative exponent factor in my denominator, I move it up to the numerator as a factor and change that exponent sign. Alright, so those are our two rules for negative exponents. Let's do some examples. Simplify and express with positive exponents only. Let's start out easy. If I've got x to the minus 4 power over y to the minus 3 power. Now notice these bases are not the same, so we can't apply our part 1 rules here, but I can notice that this numerator expression can come downstairs as x to the 4th power, and similarly this negative exponent factor in the denominator can come upstairs as y cubed. So really a one-stepper if you remember the rules properly, right? Y cubed over x to the 4th. Again, simplify and express with positive exponents only. 1 over c to the minus 10th power. Well, the 1 stays where it is. This factor will come upstairs as c to the 10th power. And anytime you move everything out, an invisible factor of 1 appears. Of course, factors of 1 are redundant, divisors of 1 are redundant, so you end up with c to the 10th power, right? Let's try another one. Simplify and express with positive exponents only. Minus 6 s to the minus 2 power over t to the minus 9 power. Alright, now again the goal here is to express as simply as possible with positive exponents only. Now notice that minus 6 is going to stay where it is. There is no exponent working on that minus 6. Right? This is an implied product here, and the exponents do not touch that minus 6. Alright, so I'm going to leave the minus 6 upstairs where it belongs. S to the minus 2 in the numerator comes downstairs as s squared, right? Similarly, t to the minus 9th power in the denominator comes upstairs as t to the 9th. Alright, so I've simplified as much as I can and expressed my final result with positive exponents only. Alright, we're done with that one. Alright, now the screen. Simplify and express with positive exponents only. Two to the x to the minus 5th over x to the 11th power. Well, here one of these factors, variable factors, has a negative exponent, one of them has a positive exponent. Well, my goal here is positive exponents only. Notice that 2 is going to stay in the numerator. That negative 5 exponent works on that x base only. Exponents before multiplication, right? Alright, so what I can do then is move this downstairs, leave the 2 where it is, and leave the x to the 11th where it is, because that already has a positive exponent. So I end up with 2 divided by x to the 11th times x to the 5th is 2 over x to the 16th power, adding the exponents in the denominator product. Alright, something a little nastier. Simplify and express with positive exponents only. And this one looks a little nastier. A to the minus 2 power cubed divided by a squared to the minus 4th power. Alright, more than one way to do this. I always like to take the path, what I call the path with the least ink. In this numerator, I've got a power of a power. And I know when I've got a power of a power, I multiply the exponents. So in that numerator, I end up with a to the minus 6 power, because minus 2 times 3 is negative 6. Similarly, downstairs, I'm going to have an a to the minus 8th power. Now, there's a number of different ways you can get to the same correct result here. You could be formal and apply the quotient rule. You could be a little more informal. What I'm going to do is move this upstairs as a to the 8th, getting a positive exponent. Move this to the denominator level as a factor and get a to the 6th power. And then it's easy to see 6 factors in the numerator. 6 factors of a in the denominator cancel out all but 2 factors of a in the numerator. If you want to apply your quotient rule for exponents that we talked about last time, when you're dividing the same bases, you can keep that same base and subtract the denominator exponent from the numerator, and I get a squared as a final result. All right. Oops. Hang on a minute. I got trouble here. All right. I just keep going. Simplify and express with positive exponents only. Look at this one. You got a quotient. A to the minus 2 power times b to the 5th in the numerator, divided by 5b to the 8th in the denominator, in turn raised to the minus 3 power. And there's a number of ways to handle this, and I'm trying to look at the best way. Well, what I'm going to do is simplify within the parentheses first, before I deal with this outer exponent. Because I see b to the 5th over b to the 8th, that reduces to b cubed, a factor of b cubed in the denominator. Alright, now you might debate about which path to take next. What I'm going to do is say I've got 3 factors in this quotient, and I can distribute this outer exponent over all 3. Watch. A to the minus 2 power times raised to the minus 3 power is a to the 6th power. Remember, power over power, you multiply the exponents. Okay. Now downstairs, I'll get 5 to the minus 3 power. Let me write it just like that. And then b cubed to the minus 3 power is going to be b to the minus 9th. Alright, that's one possible way to grind this one out. And let's see. I can then move this upstairs as 5 cubed. Well, that's 125. I can move this upstairs as b to the 9th power. And of course, an a to the 6th power was already sitting upstairs in that numerator. Final answer here, 125, a to the 6th, b to the 9th. Alright, there is a little shortcut, maybe a little better way here. If we invoke what we're going to call a new rule here, quotients to negative powers. How to simplify expressions like this if you've got quotients raised to negative powers. Let's say I've got 2/3 raised to the minus 4 power. Alright, by definition, that is equivalent to 1 over 2/3 to the 4th power. And that denominator expression is equivalent to 2 to the 4th power over 3 to the 4th power. I can distribute an exponent, an exponent over a quotient as covered in part 1. Alright, notice I'm taking a number, dividing it by a fraction, and equivalently I can invert that divisor, fraction, and multiply. Invert and multiply, right? Alright, now factors of 1 are redundant, so and 3 to the 4th power over 2 to the 4th power is equivalent to 3 halves to the 4th power, is it not? Look what I've done here. I can bypass all this busy work and just notice if I've got a fraction to a negative power, or a quotient to a negative power, I can equivalently invert that quotient and change the exponent from negative to positive. Right, this suggests a rule in general. If I've got a quotient raised to a negative power, I can invert that quotient and change that exponent sign. All right, very handy little hint or tool, rule I guess, when dealing with quotients to negative powers. A little bit of a shortcut. All right, let's invoke this rule in some examples. Simplify and express with positive exponents only. Let's say I've got 2/3 to the minus 4th power. Well, as we've seen, that's equivalent to 3 halves to the 4th power. Invert your fractional base and change your exponent sign. And now I can just distribute my exponent over my quotient as covered in part 1. And 3 to the 4th power is 81, and 2 to the 4th power downstairs is 81/16. And how about that same rule with some variables? Let's say I've got y squared over x cubed raised to a negative exponent, negative 3. That's an x to the positive 3 in the denominator, okay? Alright, the rule says quotient raised to a negative exponent, invert that quotient, invert that base, and change your exponent sign. And now all my exponents are positive, and it's much easier to deal with. In the numerator, x cubed cubed is x to the 9th. And the denominator, y squared cubed, is, of course, y to the 6th power. Nice, easy way to deal with negative exponents raised, or working on quotient expressions. All right, let's talk about one nasty one, and this is maybe the upper limit of difficulty in the homework assignment. Simplify and express with positive exponents only. Let me think ahead and not write too big here. I'll run out of room. A to the minus 2 power times b cubed in the numerator. Downstairs, a to the minus 3 power times b to the minus 4 power times b to the 8th power in the denominator, and that entire mess raised to a negative exponent. Alright, now don't panic. These aren't too bad as long as you maintain some good housekeeping skills here. Alright, let me think of the best way. What would be the best way, the path of least ink to deal with here? Oh, hang on a minute. I got a copy error here. Hang on a minute. I'm going to put on pause. Yeah, there's a copy error here. Let me erase this minus 3 and put minus 7. Okay. Alright, what I'm going to do is simplify within the parentheses first. Try to crunch my powers of a and b together as much as I can before I deal with this outer exponent. Alright, so let's leave that minus 3 exponent hanging outside for a minute. Now, a to the minus 2 over a to the minus 7, well, I don't want to separate this into too many steps. Right, I'll write it like this. A to the 7th can come upstairs, and a to the positive 2nd then comes downstairs. And I'll crunch those together in a moment. How about my powers of b? Well, b to the 4th minus 4th times b to the 8th downstairs is b to the 4th, right? Multiplying those powers of b together. And the b cubed upstairs I'll leave alone for a minute. And I think we can see then that a to the 7th over a squared leaves me with 5 factors of a in the numerator, and b cubed over b to the 4th leaves 1 factor of b in the denominator. All right, and don't forget we've got a minus 3 working on that, a minus 3 exponent working on that quotient. All right, now we know when we've got a fraction raised to a negative exponent, I can invert that fraction and raise to a positive exponent. And now I've got a positive exponent working on a quotient, all with positive exponents. All right, so I can distribute this b cubed. I can distribute this exponent over my quotient. So b to the 3rd power is b cubed in the numerator, and downstairs a to the 5th cubed is, of course, a to the 15th power. All right, final answer. All right, it's 27 minutes, and we'll conclude this section 5.1 Exponents Part 2, Negative Exponents.